Hello everyone! Welcome to the QD001 Smart Car teaching course, Section 2 to 5, Expressing the Smart Car's Status. Do you know why cars need status indicators while driving? That's because drivers need lights and sounds to signal intentions, like a left turn signal or a horn to alert pedestrians. Now let's learn how to make the smart car use lights and sound to provide status feedback. Part 1. What are the ways a car expresses its status? Do you know how car lights express car status? Common ones include low beam, high beam, turn signals, and brake lights. Car lights are a car's gesture signals. They convey intent and prevent collisions. Car horns are also very important. For example, honk the horn when starting the car to alert others. On mountain road curves, honk to warn oncoming cars. When reversing into a parking space, honk to remind nearby pedestrians and cars to keep clear. Car lights and sounds are important ways for a car to convey information. On the QD001 Smart Car, we use LED lights and a buzzer to express different motion states. On the QD001 Smart Car, connect the left LED module to pin 12 of the main control board. Connect the right LED module to pin 2 of the main control board. And connect the buzzer module to pin 33 of the main control board. Part 2. Smart Car Laboratory. After understanding the hardware connections of each module, let's combine motion control, LED control and buzzer control to implement a complete motion indicator system. To accomplish these functions, you'll need these new commands. This motion command integrates all 4 motors. You just need to select the movement mode and speed. No need to control each motor individually. The first drop-down box allows you to select the movement mode. Among these, left and right indicate the direction of translation, while clockwise and counterclockwise indicate the direction of turning. The second box is for entering the speed, with a range of 0 to 255. Clarify the logic before programming. After starting, execute the following in sequence. Start prompt. Move forward. Turn left. Turn right. Move forward. And stop. Each state has corresponding light and sound alerts. Now that the logic is clear, we can start programming. Step 1. Start preparation. First, define a custom block. For example, name it Start. Then make the buzzer play the E4 note. Delay for 100 milliseconds, and repeat twice. Step 2. Define moving forward. For example, name it Go Straight. Then set the 2 LEDs to the on state. And set the car to move front for 2000 milliseconds. Step 3. Define turning left. First, set the left light on and the right light off. And make the car move counterclockwise. Then, make the left LED blink 10 times. We can set it to flash every 50 milliseconds. Finally, stop the car for 1000 milliseconds. Step 4. Define turning right. First, set the left light off and the right light on, and make the car drive clockwise. Then, make the right LED blink 10 times. Step 5. Define stop. For example, name it Stop the Car. First, set up an LED brightness variable named Brightness, and set the initial brightness value to 255. Then gradually decrease the brightness. Set the LED brightness to decrease from 255 down to 0. Then, in the brightness settings for both the left and right LEDs, embed the variable brightness. And decrease the brightness value by 5 each time. Next, the buzzer plays a long E4 tone and delays for 100 milliseconds. Finally, the car stops. Next, Combine these 5 custom blocks in logical order. The sequence is: start prompt, go straight, turn left, turn right, go straight, and stop. The program is complete. Click Upload to write the program into the ESP32. Look, the smart car gives off sound and light cues while performing. Isn't this kind of car much more fun? This program is also provided in the sample program, so you can open it for reference. Feel free to share your motion indicator creation. See you in the next lesson.